It all started with isolation of the virus from an infected patient in China. The coronavirus was sequenced and its genetic information was uploaded to a public database. Working together, scientists at the NIH and Moderna identified the sequence for a key protein on the surface of the virus, called the spike protein, as a good vaccine candidate. The instructions for making the spike protein were then encoded into an instruction molecule called mRNA, which could be administered directly to patients as a vaccine. The vaccine is injected just like other vaccines. The mRNA is taken to immune cells, where it instructs cells to make copies of the spike protein as if the cells had been infected by the coronavirus. Other immune cells, shown here as red and orange figures, are then able to learn about the spike protein and develop ways to protect the person if they ever come into contact with the actual coronavirus. What makes this approach different is that you don't need to make the virus itself to make a vaccine, a time-consuming and intensive process. Instead, you use the information from the virus and administer the information directly to the patient. Essentially, the patient makes their own vaccine. This cuts out the middleman. Using this approach, NIH and Moderna were able to go from sequence to a vaccine ready for human testing in record time, just 42 days.